Hello everyone, this is Sanjay from CSIT branch. Today my AAT Tech Talk topic of computer networks is a survey of information-centric networking. This is my computer networks topic. So the current internet architecture was founded upon a host-centric communication model, which was appropriate for coping with the needs of the early internet users. Internet usage has evolved, however, with most users mainly interested in accessing information irrespective of its physical location. The paradigm shift in the usage model of the Internet, along with the pressing needs for, among others, better security and mobility support, has led researchers into considering a radical change to the Internet architecture. In this direction, we have witnessed many research efforts investigation information-centric networking, that is called as ICN, as a foundation upon which the future Internet can be built. Our main aim in this survey are to identify the core functionalities of ICN architectures, to describe the key ICN proposals in tutorial manner, highlighting the similarities and differences among them with respect to those core functionalities, and to identify the key weaknesses of ICN proposals and to outline the main unresolved research challenges in this area of networking research. Information-centric networking is a networking paradigm that represents a significant departure from the traditional host-centric model, where data is located and retrieved based on the specific locations of hosts or servers. Instead, ICN focus on the content or information itself, allowing users to request and access data by its name or identifier, irrespective of its location. Here is a survey of key aspects of the information-centric networking. Named data objects (NDOs) in ICN, data is represented as named data objects, which are assigned unique and meaningful names. These names are used to request and access data, making it content-centric rather than host-centric. Caching and content retrieval. ICN networks are inherently cache-friendly. Routers and intermediate nodes cache content, reducing the need for repeated data transfers from the source. Users can retrieve data from the nearest cache, reducing latency and network load. Security. ICN introduced security at the content level. Data is signed and authenticated, and access control is associated with the content names, making it possible to enforce content-based security policies. Mobility and multicast. ICN handles content mobility effectively. Data can be moved and accessed from different locations without changing its name. Multicast is natively supported, enabling efficient content distribution to multiple recipients. Scalability. ICN is designed to be highly scalable as the network scales with the number of content objects rather than the number of hosts or users. This can potentially simplify network management and routing. Named data networking (NDN). NDN is one of the prominent ICN architectures. It has a hierarchical namespaces and uses interest packets to request content. Content is fetched by responding with data packets. NDN has been developed as an open source project and has inspired various research efforts. Publish-subscribe. ICN supports the publish-subscribe communication model. Users can express their interest in content and the network can efficiently deliver content to interested parties. Content-centric routing. ICN employs content-based routing instead of traditional IP-based routing. Routers use content names to make forwarding decisions. This simplifies routing as the network does not have to maintain detailed host location information. Edge computing. ICN naturally supports edge computing Edge computing as content can be processed and cached at network's edge, reducing the need to transfer data back to a central server for processing. Content discovery. ICN allows for efficient content discovery through name-based routing. Users can request content by name, and routers forward these requests towards the data source or the nearest cache. Quality and service. ICN enables more granular QoS control since users can specify the content they want by name, and routers can prioritize or apply policies based on content. Challenges. ICN faces challenges related to naming schemes, content synchronization, security, and backward compatibility with existing IP networks. Transitioning from the traditional IP-based network infrastructure to ICN is a complex process. Use cases. ICN has potential application in various domains, including IoT, content distribution, content-centric networks, edge computing, and vehicular networks. The current problems of the Internet are a natural consequence, and its architecture, which are designed to address the communication needs of time in a network, was needed for sharing rare and expensive resources such as peripherals, mainframe computers, and long-distance communication links. The basic requirements from the Internet at the time was merely that of forwarding packets of data among a limited number of stationary machines with well-established trust relationships. The key design principles of the Internet made it very simple to link new networks to the Internet and enabled a tremendous growth in its size. In parallel to the Internet's growth, an unprecedented number of innovations in both the application and services running on top of it, as well as in the technologies below the internetwork layer have emerged. This is attributed to the hourglass approach followed by the Internet's protocols architecture. The network layer forming the waist of the hourglass is transparent enough so that almost any application can run on top of it, and simple enough so that it can run over almost any link layer technologies. In this section, we introduce the key concepts of the principles of the ICN and discuss how each one of them aims to address some of the current Internet problems and limitations. The discussion also sets the framework for examining the detail each proposed ICN architecture in section 3. Focus on information naming. The Internet has been transformed from an academic network of global infrastructure for the massive distribution of information with over 1 billion of connected users, 1 trillion of indexed web pages, and exabytes of annually transferred data. Users are more and more interested in receiving information content and data wherever it can be located rather than accessing a particular computer system. However, the fact that the Internet is still based on an underlying host-centric communication model requires the users to specify in each request not only the desired information but also the specific server from which it has to be retrieved from. Unless add-on functionality is used, the Internet's native network layer mechanisms cannot locate and fetch the requested information from the optimal location where it is hosted, unless the user somehow knows to include the optimal location in the request. Focus on the information delivery. The shift towards the content-centric bandwidth demanding applications require the Internet to efficiently deliver massive amounts of information and handle large spikes or surges in traffic, commonly referred to as the flash events. Focus on mobility. The addressing scheme of the Internet was designed with fixed hosts in mind, since a host's IP address must belong to the network where the host is currently attached. However, statistics show a constantly increasing number of non-fixed hosts accessing the Internet, with forecasts saying by 2015 traffic from wireless terminals will exceed traffic from wired ones. Focus on the security. The Internet was designed to operate in a completely trustworthy environment. Users and data authentication, data integrity, and user privacy were not a requirement. Indeed, the focus was on openness and flexibility in allowing the network. Conclusion. So I can finally conclude that we have attempted to provide an in-depth survey on how ICN research landscape. As a first step, we identified a series of issues in the current internet architecture that motivate a fundamental rethinking of how the internet should operate in order to cope with new and emerging requirements. Several ICN architectures have been proposed to address some of these requirements, such as need for client information delivery and mobility support. So, I can tell that there is that therefore an urgent need for the further research and quantitative studies for evaluating the benefits and potential performance gains brought by this new architectural paradigm. ICN is evolving area of networking research with the potential to address some of the limitations of the traditional IP-based model. It is promising approach for content-centric communication, efficient data distribution. So these are my references of my topic. Thank you.